师好，我是企管四乙许奇文。These are our team members. And this is the content of the report. First, I will introduce the dataset. The dataset we choose is Oregon Department of Forestry Statistics Wildfire from 2000 through 2022. The source of the data is the U.S. government open data portal. There are many variables in this dataset, but most variables are meaningless, such as serial file name, full file number, district file number, so we delete them. And some of the variables are repeated. For example, regional variables include area, district name, unit name, and country. In order to avoid there are too many variables after one-hot encoding, we only choose area for our regional variable, because area has only 3 different values. Also, there are many time-related variables, such as ignition date time, report date time, and discover date time. We only choose ignition date time because we found that the value of the variable are almost the same. Then we use Excel to divide ignition date time into fire year and fire months. We can see that finally we have 10 variables, and size class is our target value. Next is data parsing. Continuous variables with missing value are replaced by min. Categorical variables are replaced by mode. Because the year and month are not suitable to be replaced by min, so we use mode instead. The value of size class from A to G represents the file level, so we use one-hot encoding. And the value of other category variables are not associated in order, so we use label encoding. Then we split the data into 80% training and 20% testing, and use 2023. 0617 as random states, because the day is our graduation ceremony.
我是统资四乙李董。Next, I'm going to introduce the part of the decision tree.
教授好，我是经济二乙的江瑞德。I will now explain the part of the modeling decision tree in Python for my reports. First, I will describe how to determine the modeling parameters. The parameters n range from 2 to 10, while c range from 0.05 to 1, in increments of 0.05. From the chart, we have seen that when c is setting to 0.05, the modeling accuracy consistently remains at 0.9376. Then we apply this model to the test dataset, achieving an accuracy of 87.9%. Therefore, we conclude that this model does not overfitting or underfitting. This is a trait of the decision tree of all attributes. Now I will talking about how to selection the attributes. We have 2 methods. One is selection by chi-square distribution method. The other is selection by decision tree method. Because the chi-square distribution method selects all attributes, so we will listen to compare it with the decision tree method. Just as before, n equal to 2, c equal to 0.05. We have the highest accuracy at 0.9842. Then we apply this model to the test dataset, obtaining an accuracy of 98.34%. Therefore, we conclude that this model does not overfitting or underfitting. This is a chart of a decision tree for solution attributes.
Part is C4.5 arbitrage. First, I use C4.5 arbitrage to do modeling in order to find the best parameter of the model. Set n to find the best parameter from 2 to 10. Then I found the best accuracy rate is 0.92, when n equal to 8. So I choose C4.5 n equal to 8 as the best parameter. This is a decision tree of the all attributes I built with R, but the data is too huge, so it is not printed clearly. This picture is a decision tree of selected attributes I built with R. You can see when its total average 1 less or equal to 7, the size class is A. When its total average 1 more than 7 and its total average 3 less than or equal to 9, the size class is B. Next is comparison chart I drew. It is a unified table of modeling and testing the correct rate of all attributes and selected attributes in two ways. It can be found that when selecting all attributes with R, this is a higher accuracy rate, but when using a selective attribute, there is a higher accuracy rate with Python. However, you can know that you are using Python to find parts the highest accuracy rate of the variable test is in danger, but it's the best. Thank you.
Next, we have the optimistic bounds and the pessimistic bounds. First, the error rate for the optimistic bounds is calculated by subtracting the accuracy of the test data set equal to 12.10%. For the pessimistic bounds, it is calculated as the number of leaf nodes in the decision tree multiplied by 0.5 to counter of prediction error divided by the total number of data sets, and the result is 12.59%.
我是企管四乙的李玉山。The next is association analysis. In order to take all variables into consideration, we discretize the continuous variable in the data, as shown in the table. To make the interval more meaningful, we categorize fire months according to the seasons in the United States. For a fire year, we classified it based on significant events related to global warming. The signing of the Kyoto Protocol in 2005, the signing of the Paris Agreement in 2016, and the United States withdrew from the Paris Agreement in 2020. Using a support of 0.05 and a confidence of 0.8 as the threshold, a total of 10 rules were found in R. We selected rules with higher confidence of the target variables for explanation. In R, it was observed that fires with a total accuracy value of less than 0.01 have a 100% of confidence in being classified as Class A. For fires with a total accuracy value greater than or equal to 0.5 and longitude falling within the range of -125 to -123, there is an 80% of confidence in being classified as Class B. Due to the majority presence of data points in Class A and B, other categories were treated as noise and filtered out. In the Python result, a total of 1,211 rules were found, which results are the same as in R.
老师好，我是经济四甲的李嘉轩。Next, I will explain two classifier algorithms. And the first one is support vector classification. In our group, we imported SVC stand up using the linear SVC coding class. We tried 4 different sets of parameters, and they are first, C equals 1 and gamma equals 0.1. And second is C equals 5 and gamma equals 0.1. And the third is C equals 10 and gamma equals 0.1. And the last is C equals 10 and gamma equals 0.01. And here are the accuracy scores for these 4 parameter sets. And we found that when C equals 10 and gamma equals to 0.1, we achieve the highest accuracy score and the lowest number of incorrect predictions. Okay, the second algorithm is random forest. Similarly, we set 4 different parameters combinations, and they are first, N estimators equals 200 and max depth equals 8. And second is N estimators equals 500 and max depth equals 8. And third is N estimators equals 500 and max depth equals 10. And the last one is N estimators equals 200 and max depth equals 2. And here are the accuracy scores for these 4 parameter sets. And we can observe that when N estimators equals 500 and max depth equals 10, we achieve the highest accuracy score.
大家好，我是企四乙陈伟明。I will talk about the KNN. First, to determine the best K and highest accuracy, the loop range is set from 1 to the 18,781 based on the training data set. Second, constructing the KN model for the training dataset, then predict the target value for the testing dataset and calculating the accuracy and storing it in the list ACC. Third, max ACC to obtain the highest accuracy and ACC index max ACC plus 1 to obtain the best K. Finally, the more iterations the loop performs, the more time it takes. I spent 18 hours to get the highest accuracy is 0.7247 with the best K is 17. Next, I will talk about the voting and compare the performance of the 5 models. After constructing the random forest, SVN, and KN models with the best parameters, the models are incorporated into the voting ensemble and computed the accuracy of the hard voting and soft voting. According to the result, we have determined the SVN models has the highest accuracy among the 5 models.
大家好，我是企管四乙李云泽。Next, I will introduce the hierarchical clustering in K-means. First, according to the script plots, the data can be divided into either 6 groups or 8 groups. However, upon examining the corresponding points, the clusters formed by dividing them into 8 groups are smoother compared to the ones formed by dividing them into 6 groups. This suggests a point of inflection indicating that it is more appropriate to classify them into 8 clusters. Moving on to the results generated by hierarchical clustering. Program suggests dividing the data into 4 clusters. However, when comparing the script plot with the SSE generated by hierarchical clustering, the SSE of the 4 cluster division is much higher than that of the 8 cluster division. Therefore, the final decision is to classify the data into 8 clusters. These are the results after K-means clustering method and the variables which are considered. And looking at the results, let's take cluster 0 as an example. Firstly, in cluster 0, the region variable NOA has a value of 0.8621. Therefore, it can be concluded that the majority of the fire incidents occurred in the NOA region, with the burn area slightly smaller than the average. Additionally, in the region variable human, it has a value of 0.9569, indicating that the human factors are the main cause of these incidents. Moreover, based on the latitude and longitude variables, it can be observed that the incidents mainly occurred in the northwest directions. According to results of the region variable, they primarily happen in remote residential areas. Lastly, the variable for the year and month shows a higher frequency in July 2010. Finally, if we use the voting based on the majority of each category as the predicted class and calculate its accuracy, the result is determined to be 0.7253, which indicates an accuracy of 72.33%.
Finally, here are our suggestions. And these conclusions are the results derived from our group's discussion and analysis. And we have observed that the majority of forest fires in the southern Oregon area are classified as Class A, indicating small-scale fires mostly caused by human activities during the summer. We recommend raising awareness about fire prevention in forests and increasing patrols to prevent forest fires. Industrial restrictions, known as Level 1 fire season only, are typically imposed in areas where Class A fires occur to minimize the risk of fire incidents. Additionally, Class B fires, which are larger in scale and often human-caused, are particularly prone to occur in the southern Oregon area, especially within the longitude range of -125 to -123. Enhanced patrols and firefighting measures should be implemented to prevent the escalation of these fires. And this is our work schedule. And thank you, everyone.